0.8362 minus 0.5, squared the whole thing, times by 0.5, times by 0.5, times by 2 is equal to 5.00005. Okay. So I have 11.9483 plus by 5.005. I got 16.9533 inches to the cube. Okay. So you can see on your own whether you take from the top or take from the bottom, the answer will be the same. Okay. So therefore, the Q at point C, which is at the centroid, this is equal to 7 times 10 to the power 3. And then we divide the whole thing by 92.569. Multiply by 16.593. 953. Okay. And then you need to divide by 2 because it's a box beam. So 7 power 3 times 16.953 divided by 92.569 divided by 2. So it's equal to 640.987. Okay. Right. So any question with this? Okay. This is this clear? Any doubt that you all need to clarify before I move on to the nail question? Are you okay? Any questions? Everything clear? Now everything, like if it is what to find the centroid, okay? If you want to find the centroid, take from the top bottom, the answer will be. So this is like this practice is like a good check, okay, to see if your answer is correct, whether you take from top or bottom, okay? Right. So I don't have any question regarding this question, right? So what I'm going to do, I'm going to proceed with homework 7. Wait, homework 7, question 5. Okay, so homework 7, question 5. Right. Okay. This is one of the confusing one. Not confusing. Not sure. And I deliberately picked this question for a reason. I want you to see something. Right. So this is our member over here. It's made of, or our section over here. It's made up of 3 individual member. Okay. So you have member number 1. You have member number 2. And you have member number 3. And all of them are joined by the bolts down here. And we have given us a spacing of S equal to 250. Okay. So determine the shear force developed in each bolt if the spacing is 250. So what we want to find down here, okay, or before I go on, there are two very important rules for longitudinal shear. Okay. Number one, the shear flow must distribute through the entire member first before the shear flow is allowed to transmit the load or the stress to the other member. Yeah, this is a longer version. Okay, and then the second rule is after the or the fastener are used to transmit the shear flow. Okay, so with this problem, we are given, I'll draw my transformation first. X, Y, Z. Okay, and we have a Y bar which is equal to 0.18676 meters. And we are also given that, or we found, okay, I don't waste time down here. Our IZZ is 0.270236 times 10 to the power minus 3 meter 4. Okay. So now I'm going to sketch. Okay, I'm going to sketch. Okay. I'm going to sketch our cross section. Oh, okay. Yeah, it's okay. Right? And then we have a bolt running through, right? Where the bolt run through, they don't tell us. Where the bolt run through, no information is where the bolt go, right? And we are aware that our geometric centroid is, if this is 250, is somewhere around here. Okay. So this is equal to 0.18676. Okay. So what did the rule say first? Right? The shear flow must distribute to the entire member. Right? So we label this as member number 1. And we label this as member number 2. Now, because this is also a wide flange, you can just consider one side. So it has to what? The shear flow has to distribute in the entire member first. Okay. Then it will transmit the load to the fastener. That's the rule. Okay. So now by looking at this, now you know, okay, I know how to find my first moment of area now. Right? So the formula to use, right, will be equal to FQ is equal to VQ over I, and this is equal to F over S. What we want to determine is F, right? So we are given V, I, S. We have to find what is Q. Okay. So from here, Q, okay, will be equal to the width is equal to 0.025. Let me see. Yeah, the width is 0.025. The depth is 0.25. The Y bar is 0.18676 minus by 0.25 divided by 2. So this is equal to 0.18676 minus by 0.25 divided by 2. Times by 0.25 times by 0.025 is equal to 386. Okay, I get 386 times 10 to the power minus 6 meter cube. Let me do it again. 0.8676 minus 0.25 divided by 2 times by 0.25 times by 0.025. Okay. 0.18676 minus 0.25 divided by 2 times by 0.25 times by 0.025. 386. Okay. So from here, our V, we know that it's equal to 35 times 10 to the power 3. Q, 386 times 10 to the power minus 6. I, 0.270236. F, S, 0.25. So from here, F is equal to 35 power 3 times by 386 power minus 6 divided by 0.270236 power minus 3. 0.25, oh yeah, syntax error. Is it 35? Yeah, 35 power 3 times by 386 power minus 6 divided by 0.270236 power minus 3. It's equal to 12 point, I get 12.855. Is there, did I put a number wrongly? 35, 35, let me do it. 35 power 3 times by 386 power minus 6 divided by 0.270236 power minus 3. Yep, times by 0.25. I get 12.498. times 10 to the power 3 Newton. Okay. So for this case, I only consider one side for the failure. So this is based on, when you see this, this is over here based on single shear. Okay.